Alright guys, I got a project here. I've been doing a lot of sandblasting lately, and the old Harbor Freight air compressor that I've stuck with for a while just cannot keep up with that much air flow. So my plan is here, I've got this old supposedly 60s Tecumseh motor, and I welded another lobe onto the intake side of the cam, so it's a dual intake lobe. As you can see, so it'll pump air. And then I've got a 8-inch pulley down here, so it's a 2-to-1 ratio. 2 rotations of the motor equals 1 rotation of this, so it has a little bit of an advantage. I made it to where the belt's going to be on a little bit loose so I can have a PTO, because it's going to be hard to start when it's under that much load. It'll be about right there, which is loose. This is a 204cc motor, I believe. This is like a 400 something cc motor. It's a 12.5, so it should have plenty of power to do that. It does have electric start. And you can see I've got a Harley exhaust bolted on there, so that makes it really quiet. So when this motor's rotating at about 2,000 RPM, which that one would be rotating at about 4,000 RPM, it should be pumping out about 20 cubic feet per minute. And the one in there, the Harbor Freight air compressor, does 4.7, so that would be really good. But my goal is only about 1,700 RPM for this, because I don't need anything crazy. But the way it works is, you've basically got your piston right here, and this is the way it spins, clockwise, because that spins clockwise for the blades. So your piston's coming down, and the intake valve opens. So it's sucking in air, and it gets to the bottom, and it closes, and it pushes the air up. The only problem is if you're compressing the air, even though the intake valve's open, it's just going to want to suck it right back through that spark plug hole. So I got this 3/4 inch check valve, one-way check valve, which at 1,700 RPM it should work fine. And I am going to keep it lubricated, so that'll get plenty of air flowing through. The only thing I need to do is actually drill this out. I got a drill bit for that. I got to drill a hole in the head, which I got a 3/4 inch tapered 14 threads per inch tap, pipe tap, and then a 13/16 drill bit, which it really calls for a 15/16, but what I'm going to end up doing is just take a die grinder and just very carefully, steadily bore out the hole, and then use my dial caliper to make sure it's in the right measurements. I was having a hard time at the hardware store finding a reducing coupler. I don't know what you want to call it, but you basically got this nipple that goes into the head here, and then here's our 3/4 inch check valve, and here's a reducing adapter right here that reduces to 1/2 inch, and then here I've got a 1/2 inch to 3/8 adapter, which goes in there. And then after that I finally have a 3/8 to 1/4 inch, which an air fitting will fit right in there for the air supply. And that check valve will prevent anything from coming back through. It'll only go out, and that'll be what we need to compress air. It kind of works out that I'm doing this on a wagon because it helps to make itself. As you can see, I have a little bit more material to work with than I originally thought, so that's good for tapping threads.